And greetings. Welcome to the Evidence and Reasons for the Christian Faith video channel. I'm your host, Salvador Cordova, and the title of today's show is DapperDino Gets a Spanking on the Obfuscations of Evolutionary Fitness, Darwinism as Religion. There was a proverb about a preacher who kept preaching the same sermon every Sunday, and the congregation eventually complained. They said, "Preacher, you gave that same sermon this week that you did last." And the preacher responded, "Well, until I see you listen and follow it, I'm going to keep preaching the same message." So there'll be some themes that I'm repeating again. DapperDino has gone on a rampage to accuse me of being slimy, a slime ball, and all these vile things, insinuating I'm lying. And my response is, look, whether I'm a slime ball, whether I'm a scoundrel, and to quote Han Solo, scoundrel, I like the sound of that. That's all like really not the real issue, is it? I mean, there are lots of liars and bad people on the planet. The important thing is there a real, is God real? Is there a creator? One would believe in a creator. It's more believable that there is a creator if it turns out evolutionary biology is basically a joke of a scientific theory, which I think it absolutely is on so many levels. It superficially looks right on the surface because of our similarity to human similarity to other animals, and then it looks like biology follows something that appears to be a family tree. But even granting common descent, how can something like the eye evolve? That was the question Darwin asked in Origin of Species, Chapter 6, in the section entitled Organs of Extreme Perfection and Complication. And I don't think DapperDino has answered that adequately. He seems to reassure himself that evolutionary theory is good by what I call confirmation bias. He spends hundreds of hours, multi-hundreds of hours, just having drinking shows about Kent Hovind. And I participated in one of these shows. I didn't drink. I felt I had to kind of punish Kent Hovind for his many sins, call him out on it. But hey, come on, 100 shows on Kent Hovind. That does not help someone. That amount of investment in time is, I guess I would give it a pass, but he never, DapperDino doesn't engage the very best arguments, in my opinion. He may engage it, he may talk about it, but he doesn't seem to ever get it. When I started to just have a 5-hour show that criticized evolutionary theory, I don't even know if he watched it, but the next day, rather than even attempting to engage the substance, he went on a campaign of ad hominem, calling me all sorts of names the next day. And my view is, hey, that's the thing you do when you don't really have an argument anymore. He just started calling me slimy and whatever, and he keeps doing that. And I'm just like, okay, the more he keeps doing that, the more it tells me he's not really able to engage the substance of what I'm saying. And I have debated him. I'm willing to debate him again on a topic that we debated before 2 years ago, maybe even almost going on 3 years ago. And since that time, I have gathered even more evidence against his viewpoint. So this was, let me show the, I'll share my screen and let me show what it was. Let me see if I have it here handy. Oh boy. I had everything beautifully queued up and then it all goes to pot at the last moment. Isn't that Murphy's Law? Okay, let me make sure I don't blow up my system here. All right. See, all right. When was the date of this? The date was, it's saying it was 2 years ago, December 1st, 2020. December 1st, 2020. And you could see it here. There's me. There's DapperDino. Evolutionary Fitness, pro or con. So my unfinished journey asked, has Dapper accused me of lying? Let's go to. Let me see if I could find something for you there. That's a good question. See if I could find it. All right. Let me put this here and we'll take a look. Let me put this there. Where's my StreamYard? Did I lose my StreamYard? Okay, let me get it back. So let me read what he had to say. For a while, Saul Cordova of Evidence and Reason seemed to have cleaned up his act from his time on Reddit, where he was commonly known as Slimy Sal. Actually, I was known as Slimy Sal before that, for his blatant quote mining refusal to engage in meaningful dialogue and rudeness. Essentially, Reddit Sal was just Donnie SFT with more education. And he uses this to describe me because I didn't watch his garbage. I don't need to, honestly. If he's going to make up stuff that, even from the title, I could tell is false. And I told him he doesn't have to watch my stuff, but this is what he said. After giving many opportunities to just watch the videos of mine, he is purported to respond to. He admits not having watched them intentionally. So, well, I said that I wouldn't, because a mistake is not a lie. There's no way he's going to prove someone is lying versus mistaken about, especially someone of, like, say, John Sanford's stature. I said, take it down, dude. I might watch it if you don't open up with something I know is false. There's no reason John Sanford has to lie about evolutionary theory, because it fails on its own demerits. He's nothing like Kent Hovind. He is far more accomplished than probably most people on YouTube on his channel, far more, as a scientist, as a famous genetic engineer whose invention happens to be a Smithsonian National Museum of American History. There is no need for him to lie. If you made a mistake, that's different. And I said, if DapperDino holds himself to the same standards where mistakes are lies, it's going to look really bad on him, because I'm going to point out where he's so mistaken. He's going to be spanked today pretty badly. So anyway, he said, he says, yesterday afternoon, before my stream with Zach had ended. Oh, gee, now he corrected it. It said had ended. Thanks, DapperDino. I see the edit there. You didn't have that word ended. Now you correct it after I call you out on it. And then I say, look, you ought to call yourself a liar, because that wasn't exactly true. Now you just kind of quietly corrected. No apologies to me. Good job, DapperDino. Sal had already started what would end up being a nearly 5-hour response stream, which he's talking about this screenshot. I'm not angry with Sal. This is pretty typical young Earth creationist behavior. I am, however, disappointed that someone I tried to have a high opinion of, whom I had just had private chats with, whom I even collaborated with more than once, has just regressed to the slimeball he was years ago when his default debate tactic was to lie about scientific paper and call people names. Don't go harass Sal over this, but feel free to respectfully let him know what a bad look this is. And then yesterday, he goes on, he says, oh, or Thursday, well, looks like the reversion to Slimy Sal is complete. Hey, look, guys, this whole drama is kind of a nice way not to engage the real topic. All right, just, I did a show and I said, had to pick that famous scene in Empire Strikes Back. Han Solo says to Princess Leia, scoundrel, scoundrel. I like the sound of that. And call me names, DapperDino. Doesn't change the fact evolutionary theory is failing. I know that because I know people higher up, very top scientists in the world, and you can kind of get a hint of it with James Tour, but there are people that are his caliber that are now questioning evolutionary theory. There are conversations all over the planet now quietly, and we know we're getting through. They don't want to hear it anymore from evolutionary biologists. Sometimes they're not even invited to the talks. I mean, Tour was taking on Jack Szostak, a Nobel Prize winner, about origin of life. This is being paralleled in the issue of evolutionary biology. What you see happening in abiogenesis is happening in evolutionary biology. That's why we have the third way, where the leader of the British Royal Society, Scientific Society, is entertaining and hosting these discussions that are critical of Darwinian evolution. And this is the stuff that's happening in public. It's happening a lot more in private because what has changed? It's the discovery of the complexity of life. The more we study it, the more implausible it seems evolutionary theory is. So, going back to this, we debated evolutionary fitness in December of 2020. We debated evolutionary fitness 2020. It was a polite debate. He was very impressed with my conduct. I have, his colleagues were saying, "Oh, Sal's such a nice guy and, very knowledgeable." And he, shortly thereafter, he voted me the #1 creationist on YouTube. I was grateful for that. But as it says in Ecclesiastes, there is a time for peace and a time for war. Okay, so I would have been glad to have more of these discussions, but he went after my mentor, friend, and colleague, started calling him a liar and putting my name in the title. And I said that wasn't cool. Someone can be mistaken, doesn't make him a liar. If DapperDino follows those, applies those standards to him, it would look really bad on him. But I'm not calling him a liar. I'm just, I'll let him decide if he's going to apply those same standards to himself, because he's going to have to do a lot of repenting after this show is over, because we're going to revisit this topic that we debated. And, at the time, I thought we had it was a very good parry. But let me give a little history about that. At the time, that was in December, I had just gotten recruited to work on the question of fitness, just gotten recruited, and I was just sharing a few pieces. Over the next 4 or 5 months, I had the colleagues of John Sanford, Ola Hosner, Bill Basner, We worked on the topic of fitness. We studied it. So, rather than just debating it, I'd already been recruited I think by that point to talk about it. So what you saw in that debate was me just kind of beginning to explore the topic. But that went on to be part of a reference work that's now on university library shelves. So don't say that I don't have at least some clue of what I was talking about, because let me see. Let me see. I think it was dynamical systems, fitness maximization. Okay, let me show it just for the record for you people who think I'm just making this up and quote mining or whatever. Let me show you this title here. This is a Springer Nature reference work, which I think I can safely say I have more priority than DapperDino in that I got something on university library shelves in a secular publication by a respectable publisher, Springer Nature. Let's see. Let me see. Does it say down here? What does it say right there? Springer Nature, Switzerland AG. That's a respectable publication. And I can pretty much say I think I have priority over DapperDino as far as even studying this topic and even writing something that was accepted in peer review that is in a reference work that is on university library shelves. So, I mean, uh, is he going to accuse me of quote mining my own self? Because I'm going to reference stuff from that work that actually just references what seems to be common knowledge among the specialists in population genetics. My co-author, Ola Hosger, is an award-winning mathematician in Sweden. He won a mathematics award in Sweden. It's a national award. And he's a professor of population genetics. So, and then my other co-author, Bill Basner, is emeritus professor of mathematics. And then, of course, John Sanford, world famous genetic engineer. So, I mean, DapperDino, you could start throwing out all your ad hominems and stuff. But you're going to get spanked, dude. I mean, your own literature, which apparently you don't take very seriously, you didn't take it as seriously as we did, kind of is the undoing of evolutionary theory if it's read carefully. And people say, well, these people still believe in evolution, to which I'll say, yes, they do, which kind of mystifies me given how badly they have criticized their own discipline and seem unable to kind of like fix the very problems that they have identified. So, at some point, you're like, okay, they can still believe it. At that point, it's not science. It is a faith-based viewpoint, which we can call a religion if you like, but it's faith-based. It's not fact-based. When they have all these problems with a theory that maybe some outsiders would judge to be deal breakers, then it's no longer a scientific theory. It's a faith-based theory. So let's cover some of that now. And let me see if I can shrink this a little bit. All right. So there again is the debate we had December 2020, but we will continue. All right. So all right. I had all my stuff beautifully queued up. There it is. So reviewing again, Some of the problems: selection-driven gene loss in bacteria. In isolation, this wouldn't be really bad, but it's not an isolated incident. There is a lot of gene loss. So Darwin's theory was that we have small incremental improvements that the so let me bring this out. I'm going to just call up the Wikipedia article here. Not that I'm saying it is a final say on things, but it does represent the common viewpoint. So let's look at our entry on survival of the fittest. And I'm just going to read through it. And this will relate to the topic of fitness. Survival of the fittest. Survival of the fittest is a phrase that originated from Darwinian evolutionary theory as a way of describing the mechanism of natural selection. The biological concept of fitness is defined as reproductive success. In Darwinian terms, the phrase is best understood as survival of the form that will leave the most copies of itself in successive generations. Herbert Spencer first used the phrase after reading Charles Darwin's On the Origin of Species in his Principles of Biology, 1864, in which he drew parallels between his own economic theories and Darwin's biological ones. This survival of the fittest, which I have here sought to express in mechanical terms, is that which Mr. Darwin has called natural selection, or the preservation of favored races in the struggle of life. Darwin responded positively to Alfred Russel Wallace's suggestion of using Spencer's new phrase, survival of the fittest, as an alternative to natural selection, and adopted the phrase in The Variation of Animals and Plants Under Domestication, published in 1868. On the Origin of Species, he introduced the phrase in the 5th edition, published in 1869, intending it to mean better designed for an immediate local environment. Better designed for an immediate local environment. And here comes a little bit of the problem. So we can define evolutionary fitness like that. But the problem is, if something, let's say something is fit for one environment, like say the water, it's unlikely to be fit for another environment, like say the desert. It's fit for the water, not fit for the desert. Although there are some interesting problems with that, because a mosquito is it's in its larval phase, its early phase, or whatever its early phase is in the water. It's an aquatic creature. And then it has a phase where it's on the ground, and then clearly a phase when it can fly. So it's able to occupy 3 different environments during its lifetime. So this is going to be problematic. But, the way Dawkins, the thing is, they'll be very precise in defining it. But if it's tied to one particular environment and you don't know exactly what environment has been in its history, you can't make an assertion that it's going to involve something like an eye. So if survival of the form that leaves the most copies of itself in successive generations, so you have bacteria that just multiply like bacteria, or figuratively speaking, multiply like rabbits. How does that lead to complexity? Why should that lead to the complexity? Because Darwin was saying natural selection he expects it to build something like the eye, as complex. But look, bacteria are not evolving eyes, and yet the slower reproducing creatures like humans, and then even their would-be eukaryotic ancestors, don't reproduce as fast. So why is complexity seen in the slowest reproducing creatures versus the simplicity we see in fast reproducing creatures. There should be a disturbing disconnect just for starters right there. The other thing is, I just showed this. What does selection favor? I showed it right here. Gene loss. And you'll say that's an isolated paper. And I'll say, well, how about this one? And I will point to one of the authors here, Richard Lenski. His long-term evolution experiment, some of the lineages created what they call mutator genomes, where they started getting lots of mutations. And it says here, genomes decay despite sustained fitness gains. That means the creature that is making the most copies is the one losing genes. And then we have this by probably the top evolutionary biologist in the world, in my opinion, would be Eugene Koonin. Genome reduction is the dominant mode of evolution. Okay, so I mean, this isn't rocket science, DapperDino. I mean, how can you take a microbe that has, like, let's say, a genome of 4 million bases, and you multiply it by about 750, that'd be about the size of the human genome, 3.3 gigabases. How do you have a process of losing genes when you need to be adding DNA to make something as complex as a human? And not just genes, but you have all this non-coding DNA that we're realizing is probably really important to the development of the organism. We're finding that out more. We're finding that out with the RNA phase separation and the ALU elements being being part of the epitranscriptome in RNA editing. I mean, this is this should be brutally obvious that the dominant mode of evolution is gene loss, and then we have some mysterious, unexplained reasons why suddenly there's this just burst of complexity out of nowhere. But if laboratory experiments, the dominant mode is gene loss to be able to create faster reproduction, and we have examples even like with Spiegelman's experiment, this is not a natural tendency toward creating organs of extreme perfection and complication like the human eye. You could say you still believe it, but it's a faith statement. It's a faith statement. It's not anywhere near the structure of a real scientific theory. So, I mean, DapperDino, I think you're going to have to deal with this. I mean, you could be just going on your usual tirade of, your now current tirade of just going after me personally, but you need to explain your definition of fitness. DapperDino, you're the one that was promoting this idea of fitness based on reproductive success. But the consequence of that is you get outrageous statements like this, where genomes decay despite sustained fitness gains. The problem is with the definition of fitness, and it's an empty concept, because all it does is say, look, the thing that reproduced the most is the thing that reproduced the most. Well, duh. What you have to do is connect the thing that reproduces the most leads to the emergence of complexity. If so many of our observations, observationally in the present, and even kind of a reconstruction like what Koonin did, says that the dominant mode of evolution is loss of genes, and not really more like the loss of DNA, because Koonin here even talks about intron loss in his paper. Wolf and Koonin talk about intron loss. So even the non-coding DNA, see, extensive loss of genes and introns, extensive loss of genes in introns. So how does a process of reductive evolution, or they call it, I guess they might call it genome streamlining. How does a process that's removing DNA lead to an increase of DNA? Why don't you answer that, DapperDino, rather than going after me personally? You're going to say, well, there are exceptions to it. You just need to imagine. Okay, wait. I have to imagine? You mean you don't have facts? You don't actually have facts? You have to kind of just accept it on faith? Okay, faith-based statement. That's a faith-based viewpoint. That is not a fact-based viewpoint. You have not demonstrated any theory that shows that there should be an adequate, sufficient tendency for complexity to arise. If you're going to invoke natural selection to be the creator of complexity, there's a problem there, because natural selection being survival of the fittest being the one that makes the most babies, you have to make that tie. And there is a problem in that the most complex creatures on the planet are sometimes the most slowly reproducing. You've already got a disconnect there. And you're going to say, well, maybe there are this or that. I don't care. Maybe it's not a scientific theory. It is, a high quality scientific. Maybe it is a speculative theory. You want to call it science? Sure. Then you can call a lot of science, a lot of things science, if you allow any sort of kind of like speculation that has just flimsy support as science. Then, well, okay, then a lot of things qualify as science that maybe shouldn't. So look, it's a faith-based theory at this point, and it's not looking good. It is really not looking good. But let me just now pick on what I call the Doofus McDuff viewpoint of natural selection. I call this the Doofus McDuff viewpoint of natural selection. So I was talking about the difficulty of evolving eukaryotic components, and some Doofus McDuff on there said, look, there is so much evidence of natural selection in gene regulation. And I'm just like, whoa. And just like, how do you know that? How do you know natural selection was at play in the past? First off, Kimura's theory of neutral evolution says most molecular evolution has been neutral. That means absent of natural selection. Most. So right off the bat, Doofus McDuff didn't account for that. The other thing is, I have looked at diagrams like this a lot, where we take a gene sequence and we take that same gene, that what we call the homolog, in a variety of other species. So I think B. taurus is a cow, M. musculus is a mouse, Gallus a bird, tropicalis, Xenopus would be a frog. I don't know what J. jaculus is. Daniel Riero is a zebrafish. This is a fruit fly, D. melanogaster. I don't know what this is. S. cerevisiae. That's a yeast. And we could look this up. But you could see that, like in one, this is called a multiple sequence alignment. And you could see in one column, they're all G's here. That's called a glycine. And you could see how when we highlight the colors here, it highlights what we call evolutionary conserved. I don't know, there's an R here, but it's mostly K. But you could see that there are a great number of similarities across the species. And so evolutionary biologists will say that's evidence of conservation, which means natural selection is picking for those. But there's a problem here. Look, if we took say a group of creatures that needed hearts, and you started pulling out the hearts, you'll say, oh, natural selection selects for the heart, therefore selection evolved the heart. There's a problem with that. There's a subtle problem, and you have to think through this. It's an easy mistake to make. You can't preserve a trait that you don't have. You can't keep what you don't already have. Think about that. You can't keep what you don't already have. We are looking at creatures that already have these features. The fact that they die when some of these features are gone doesn't mean that, one, there's a problem here. What you have demonstrated is it might be essential for life. So that raises the question, how could it be alive without that? These dumb evolutionists will say, well, look, that proves it evolved. I'm just like, look, no, it proves that it's dead without it. Is that right? It does not absolutely prove that it evolved. It proves that it'd be dead without it. So if you start pulling out these essential features and the thing dies or gets really sick, that really disproves it needs it. It doesn't prove that it evolved it when it didn't have it. Because I could come back and say, well, look, if it didn't have it, then either it's dead, or at the very least, you haven't proven that it evolved it. The fact that it exists now doesn't mean it evolved naturally. That is a faith-based statement. And by natural, I mean like within normative expectation. So this was a dingbat, doofus McDuff explanation that this is evidence of natural selection. You can't select, quote unquote, select. I don't like that word. You can't, quote unquote, select for something you don't have. You can't select for something with foresight to like, oh, maybe this will be useful in the future. Because again, natural selection is the one who makes the most copies. So let's say you have a simple creature. Okay, we'll just do this. Okay, remember, selection driven gene loss. Selection driven gene loss. What does that mean? If it's not absolutely needed, there is a metabolic expense. There's an expense of resources and copying to sustain that. So if you're making something more complex, it might actually, in one given environment, cause it not to reproduce as fast. Therefore, it is quote unquote selected against. There's a strong tendency then for simplicity, whereas there is a problem of creating what we call extravagance. So if you look at the peacock's tail, why would something as ornate as a peacock's tail evolve naturally? When Darwin saw the peacock's tail, he said it made him sick. It made him sick because that level of extravagance was more consistent with the pre-Darwinian view. In the PBS series on evolution said the view before Darwin was these creatures had all this extravagance and capability that was way beyond what was needed for reproductive success, so that men would turn to their creator and wonder at their creator. And I think that was correct. That was correct. I mean, that's just an opinion. That's not necessarily scientific. But it bothered Darwin that that's the way he saw a lot of things. It had capabilities that seemed to go against the idea of just rote reproduction. So he was looking at the breed, all these breeders changing things. But the thing he failed to realize is that's intelligent selection. Intelligent selection can do things that are far beyond rote survivalism. Intelligent selection can choose features of creatures that are beyond just kind of rote survival in reproduction and making copies. So we actually know this in the present day. For some reason, highly intelligent women have 25% higher incidence of childlessness than those that have non-genius IQs. And some demographers or geneticists or evolutionary biologists have realized this means that intelligence is probably on the decline. See, if we were selecting for intelligence intelligently rather than natural selection, we could maintain that. But that trait is slowly deteriorating. We're, in other words, getting dumber as the generations move on. And this is, by the way, a testable prediction. So this should raise questions. I mean, right there is a problem. We're seeing this unfold in real time where there's loss of capability because of the tendency towards simplification. So rather than being an agent for the emergence of complexity, like say intelligence, so-called natural selection is actually destroying complexity. There's a tendency towards simplicity. And so how to get around that? The evolutionary biologists will resort to obfuscation and misdirection and just confusion. They don't actually come to terms with the difficulty that this really poses. And, I'm being on the receiving end of that. But so, but I guess all the ad hominems and all, we'll just have to bear with it. But the thing that bothers me is all this obfuscation about what fitness is. Because what I got, if you read The Blind Watchmaker, the idea is if something's more evolutionary fit, that means it's going to, the insinuation is going to naturally evolve to complexity. If you look at Dawkins' book, The Blind Watchmaker, he actually uses intelligent selection for his weasel genetic algorithm and kind of represents, he said, this is a cumulative selection and gives the insinuation this is how complexity evolves. But he doesn't cite actual experiments where you're losing complexity. He doesn't deal with that. Neither does, I believe, DapperDino is willing to deal with that. So, I mean, we look at, okay, so we have something called equivocation where, there's one term that's used by someone one way and then they use it a different way to make their point. So let's give an example. A feather, let me find it. There's one on Wikipedia. I don't want to botch this. Let me just read this from Wikipedia. Otherwise, I'll botch it. The word equivocation. A logical fallacy is used a lot in evolutionary biology. In logic, equivocation, calling two different things by the same name, is an informal fallacy resulting from the use of a particular word expression in multiple senses within an argument. So here's an example. Since only man is rational, no woman is a man, therefore no woman is rational. A feather is light. What is light cannot be dark, therefore a feather cannot be dark. Just think about that. So there are many pillars of evolutionary biology. I'd say the biggest pillar is equivocation, making an argument by leveraging multiple meanings of the same word, and usually these meanings are different. So when one can use the word selection, do you mean intelligent versus stupid selection? Darwin represented natural selection as intelligent selection when it's really stupid selection. What do I mean by that? He had a whole chapter on breeders. Breeders are intelligently selecting. Out in the wild, it's stupid. There is no goal. So the breeders had a goal in mind to track traits and to select for them. Whereas in the wild, there's none of that. It's just raw reproduction. So Darwin equivocated. The other pillar of evolutionary theory is non sequitur. Okay, example of non sequitur. That which makes the most babies makes the most babies. Okay, that's a tautology. It's a premise. But then to say that leads to the evolution of complexity, that's a non sequitur. It's like saying 2 plus 2 equals 4, therefore the sky is blue. Eh, well, if it's night, it's black, and there are times when the sky is kind of reddish. So 2 plus 2 equals 4 does not necessarily lead to the sky is blue. It's a non sequitur. Plenty of non sequiturs. Then circular reasoning. Um, uh, Evolution is true. Natural selection is true, and that's what natural selection created. This. Let me show this. Let me show you a circular reasoning. This is Doofus McDuff's circular reasoning. Natural selection created this pattern. Therefore, this is evidence of natural selection creating it. And then the non sequitur is, oh, we knock out what is conserved, and it dies. Therefore, that proves selection creates it. That's a pretty subtle non sequitur. So there are. I mean, I began to see the light clearly when I picked up from this book, Atheist. What is it? Internet Infidels. And I don't know that they still have it. Internet Infidels. Book on logical fallacies. They had this thing called, it's something a lot, and there's 60 logical fallacies, and I could see all of them in evolutionary theory. You don't see that in other real scientific disciplines and theories, like, say, electromagnetism within its classical domain. Definitely. Quantum mechanics, celestial mechanics, geometric optics. You don't see that. You see plenty of it in evolutionary biology. Equivocation, circular reasoning, non sequiturs. And there are probably some more. Oh, well, the usual ad hominems. That's the basis of evolutionary theory. Circular reasoning, equivocation, and non sequiturs. I probably will find some more. They have lots of things like literature bluffs, hasty generalizations. It was a manual on understanding evolutionary theory. If you want to understand evolutionary theory, look at the book, look up logical fallacies, see which ones you can identify within evolutionary theory. And they could eliminate a lot of those by saying, well, we just believe it. We accept it on faith. Then I'm fine. Hey, I'm a religious person. There are things I can't prove, but I accept on faith that they're true. And I just wish the evolutionary biologists would stop pretending that they actually have a scientific theory and just admit they have a religious theory, faith-based theory. And if you think I'm overstating my case, Michael Ruse, an atheist, our Darwinist, said Darwinism as religion. He wrote a book. So, this isn't me saying that. That's one of your own evolutionary biologists saying that. So, I'm now going to get into the nerd torture section of my talk. And Dan Stray said, yes. It's frightening how little evolution is scrutinized and held to such low standards. Yes. It is. It does. I had a professor, Chris Thompson. He's a professor of neuroscience at Virginia Tech, someone I debated. And I asked him, do you think evolutionary theory is as good as electromagnetism? And he said, yes. My jaw dropped. I said, okay, electromagnetism, the theory of electromagnetism, enabled the generation of electricity and the use of motors. So just think about life without electricity. That is life without electromagnetism. He couldn't, his field of neuroscience. Okay, what is one of the fundamental axioms of electromagnetism? There's a positive and there's a negative. A positive and a negative. You cannot even do neuroscience without that fundamental aspect of electromagnetic theory, because you have what they call membrane potential in nerves. And I'm just like, dude, your whole discipline will fall apart if you don't have no conception of charge, of like positive, negative, or the quantity, and things like voltage and current and resistance and capacitance. All that will fail. You will not even be able to do chemistry where you're dealing with ions that are, you have positive and negative ions, and you have neutral atoms. And like, come on, dude, you're not going to argue and say evolutionary theory is as good as electromagnetism, because there are lots of neuroscientists that I know personally, not just neuroscientists, but scientists in general who work on the cell. And I've had some of them on the show, and I'll have even more that don't believe in evolutionary theory, but they believe in electromagnetism. That should tell you something. It is unnecessary that evolutionary theory is unnecessary as a science for the operation of so many scientific disciplines. The only place it helps people is evolutionary biologists. It helps them pay their mortgages and also kind of feeds the atheistic viewpoint. It's a great, William Provine, Cornell University, colleague of Dr. John Sanford, said, evolutionary biology has been the greatest engine of atheism. That's what it's good for. It's not really good for science. People say, well, look at all the medical developments we have because of evolutionary biology. And just like, whoa. So if we have a sheep and we use that as a model organism to humans, how does that justify evolutionary theory? I could just as well say, look, God made the sheep so that they could die in our place, and by that sheep's stripes we are healed. I happen to know, I interviewed, and I will release it after it is edited, a scientist who's a thoracic surgeon, doesn't believe in evolutionary biology. He used sheep to test heart implants. And, I've told creationists, stop trying to say that we're very, very different from monkeys and chimps and whatever. You'll be very grateful that we don't have to use human embryonic stem cells from aborted fetuses to do medical research. God has provided us creatures that are similar enough to us that we can sacrifice them in our place so that we can be healed. Now, doesn't that resonate like something you've heard in the Old Testament, where these innocent lambs were sacrificed and they were a picture of the one true Lamb of God, Jesus Christ? If we just assume that we have these model organisms that are gifts of God to us, we could do medical science just as well without evolutionary theory. I would argue we'll actually do it better, because we will look at these things, these model organisms, as gifts from God, and we won't be sacrificing and aborting fetuses and harvesting their body parts. I was so blessed, like last weekend, to meet quite a number of researchers. One of them was figuring out how to epigenetically reprogram heart cells so that you could regenerate tissue. You didn't have to use embryonic stem cells from some foreign host. You could use the person's own cells, reprogram them. They will regrow nice long telomeres. Their cells will be nice and youthful looking, and the prognosis is good that they'll live much longer lives as a result. And this all began with research on creatures that were similar enough to us, but not us. It began with research on the intestines of pigs, research on rats and mice and sheep. And it led then to clinical trials and then FDA approval. So I'll say similarity proves similarity, doesn't necessarily prove evolutionary theory. You could just as well assume, and I'm working on projects that will show there are patterns in biology that, and I've talked about this on my channel, the direct coupling analysis, the nested hierarchies of biology are better explained by the foresight of a designer that enabled us to use direct coupling analysis to predict protein folds. And then also organisms are basically oracles to understanding human biology. That term is not unique to me. It is Paul Nelson who gave me that. Yes, reprogram is definitely not random. So Yamanaka won the Nobel Prize for discovering what is now known as the Yamanaka factors. You can basically reboot the cell. There are lots of cells in the body you can just reboot by supplying these 4 Yamanaka factors. It will change the epigenetic programming. It's kind of like a reboot, clears out the memory. The cell reverts to a very youthful state, and you can generate all sorts of cell lineages from that. It is what this researcher discovered, and I will release the video on this as soon as my my co-host Rebecca Davis completes the editing on that show. You'll see that it's better that you don't totally reprogram. You only reprogram select parts of the cell rather than doing a reboot. Sometimes you don't want to do a whole reboot. And when you can just do kind of a soft, kind of just, I guess in the computer world, you call it rollback to an earlier version rather than a full reboot. You roll back the software to an earlier version. The heart cells will then start to grow, and you have these exosome signaling exchanges in the extracellular matrix, and it also starts to modulate the protein expression inside the cell. There's a communication between the extracellular matrix and heart tissues with the cells, the cardiomyocytes. When you modulate this, when you set up that, and it's reprogramming itself, it's beautiful. You're able to regenerate heart valves. I talked to a thoracic surgeon, and he does not believe in evolutionary theory. So, you have these YouTube shows that they just like to focus on Kent Hovind, who I despise. He may claim to be on the same side of the argument as I am, but I often say with friends like that, who needs enemies? He's done such reputational damage to creationism. He may as well have been a Darwinist plant because he behaves so badly. And so some of these channels just focus on him and have drinking shows and just bash him all the time and just avoid dealing with subjects like what I'm talking about here. So again, you don't need evolutionary theory to be able to use model organisms. So without that, then what good is it? Seriously, what good is it? It's just an engine of atheism. It's not advancing scientific knowledge, and its core claims are suspect, starting with genomes decay despite sustained fitness gains. Genomes decay despite sustained fitness gains. This is an embarrassment, guys. Genomes decay despite sustained fitness gains. That shows the definition of evolutionary fitness is defunct. It is useless. And I'm not the first to point that out, by the way. R.H. Brady did a good job of it. And so, as I said, when I had worked on that publication in Springer Nature, we began to discover this wealth of literature that basically self-destructed evolutionary theory. And yes, I was kind of perplexed how it was that despite all of their discoveries and self-criticism, they still believed it. I'm like, okay, it's a faith statement. And as Mark Twain said, I guess this is something related. He said, don't believe your eyes when your imagination's out of focus. Something like that. Or faith is believing something you know ain't true. I wouldn't take that too literally, but I think in the case of evolutionists, that's definitely true. They believe something they know ain't true. I mean, look at all the data I just put forward, saying you guys have a lot to deal with. You have a lot that you haven't proven that you should prove before you say it's fact. At the very least, you have a theory that has a lot of problems that need to be resolved before you assert its fact. Otherwise, it's just faith assertions. It doesn't qualify relative to other operational sciences like electromagnetism, etc. So if that's not enough, let's hear it from the evolutionists themselves. I was accused of quote mining this. Why don't this by Andreas Wagner. And I'll just read the paragraph in entirety, and then I'll read the source document. Beyond the commonplace that fitness means the ability to survive and reproduce, fitness is difficult to define properly and nearly impossible to measure rigorously. This is really bad. I kind of get why they built the concept of fitness. Is if Lenski can prove that he made more fit bacteria, then yes, it seems like there's a clear path then for fitness to just keep growing and growing and growing until you go from simple to complex. You go from a microbe that's simple to a creature that's complex as a human. But people have been missing the fine print. The fine print is in Lenski's own experiments. Genomes decay despite sustained fitness gains. Genomes decay despite sustained fitness gains. There was genetic loss. Genes are lost. Natural selection destroys genes. We have abundant physical, experimental, observational evidence that's unequivocal. What we have an absence of is genomes kind of accumulating complexity that they didn't have before. They might exchange capability. In the case of Lenski's experiment, there are kind of two phases. It exchanged capability. It destroyed a functioning regulatory circuit with a copy from another one. It basically broke the regulatory circuit, and then people were oohing and awing that, oh, this is going to lead to a path of novelty, but it's really bad. God willing, in a few weeks, I'm going to have Scott Minnick on this channel. And if I don't get him, I'm going to get his assistant, Dustin Van Hofwagen, or something. I can't forgive me, Dustin. And so Lenski had this experiment that had 68,000 generations, 15 years, and out pops this citrate plus bacteria. And Scott Minnick, being a microbiologist, and the 50 papers in all the prestigious journals, and they were oohing and ahhing, and they gave Lenski membership in the National Academy. I'll tell you what's really embarrassing. Okay, so 68, 30,000, 68,000, I don't know how many, tens of thousands of generations. Scott Minnick figured out that the reason it took so long for Lenski to evolve his bacteria was he was working with defective bacteria. He was working with defective bacteria, something to do with this succinate or something, transporter or whatever. I don't know the term. Dr. Minnick does. And he figured out if you start off with a more capable bacteria, you can evolve the trait faster. So he was able to evolve this in 100 generations, sometimes in just 12 days. So Lenski, 15 years, 30,000, 68,000 generations, and then he's, oh, look what great discovery we made. But Scott Minnick was very smart. He's an ID proponent, by the way. He was in the infamous Kitzmiller versus Dover trial. Scott Minnick figured out that Lenski was using degraded bacteria. If he'd used better bacteria, that didn't have so many knocked out genes, disabled genes, he would have evolved the trait way faster. And so Scott Minnick was able to do it in like less than 12 days. And by the way, he did it 46 times over. 46 times. So this is what's going to be embarrassing. A creationist could evolve bacteria hundreds of times faster than an evolutionary biologist. I mean, that's got to hurt. That's got to hurt. Why? That's because of the power of intelligent selection. Scott Minnick was able to identify the species or strains, I think the proper term is strain, the strains of bacteria that would be more capable of evolving than Lenski could. Lenski was resorting to stupid selection, and stupid selection took it 68,000 or 30,000 generations in 15 years to evolve that citrate plus mutant that everyone's crowing about. And here Scott Minnick uses intelligent selection. He finds a better bacteria, a better strain of E. coli that I think it was the strain that Barry Hall used. He figured out this is really easy to evolve, because if you start out with something a little bit more capable, and then you have a damaging mutation that causes it to knock out a regulatory circuit, you're going to develop this citrate plus mutant. He did it 46 times, sometimes as short as 12 days and maybe 100 generations. And Lenski took thousands. So this is embarrassing. And then on top of that, Lenski's strains, many of the lines started to develop loss of genes. Hence, genomes decay despite sustained fitness gains. So I want to say, you take that experiment, read the fine print. This is a disaster. And, I hope when Dr. Minnick is on my channel, I think I could share this. He said, this is like kind of evolving Chihuahuas and poodles. What Lenski did. What Scott Minnick did was evolve wolves and coyotes. That bacteria that Lenski supposedly evolved is pathetic. It will die. It will not compete. And he is just trumpeting this to all the rest of the world as some evidence that, hey, evolution works. And it's like, well, it kind of goes in the wrong direction, Lenski. I mean, I don't think that was really, it's buried there in the fine print. So you can kind of clear your conscience that you weren't lying. But, it is fine print after all. And, that shouldn't assure anyone that evolution can lead to the emergence of complexity. That's what the theory of natural selection was really designed to address, and as articulated in Blind Watchmaker. But all of that is just ruse. It's a smokescreen. It doesn't work. Not theoretically, not experimentally, not observationally. The only place it works is in the imagination of evolutionary biologists. So, Rebecca has missed the first hour, and now she's just going to hear the nerd torture. Rebecca, you dropped in at the worst possible time, because now we're going into the nerd torture section of this talk, and it's something you've heard before. So I'm sorry, Rebecca, you missed the funner part of my talk. Now we're going to nerd torture mode. Beyond the commonplace that fitness means the ability to survive and reproduce, fitness is difficult to define properly and nearly impossible to measure rigorously. All right, guys, you can measure weight. You don't necessarily have to define kind of rigorously like mass or weight. You can create a method of measuring it. So you go to the National Institutes of Standards or the SI. It'll define how, if you compare it to this thing that they have, or they can define, okay, like the kilogram. So definition. So they have a definition of the kilogram. So in this here at the National Institutes of Standards or somewhere, they have something that defines exactly 1 kilogram, and you can compare it. Kept in a triple locked vault in the outskirts of Paris. I'm sorry. A platinum iridium cylinder was officially called the international prototype of the kilogram. It even had the nickname Le Grand K, the big K. The accuracy of every measurement of mass or weight worldwide, whether in pounds or ounces or milligrams and metric tons, depends on how closely the reference masses used in those measurements could be linked to the mass of Le Grand K. And they have since redefined how to define a kilogram, and therefore you can define then other measures. So Rebecca and I are going to have a discussion about hell. So that's an inside joke. So, And then you can also have, like, you have the Kelvin scale for temperature. You can tell if something's hotter than something else. In most cases, there are a few pathological cases that it's a little ambiguous. So you can also measure length. You can measure time. You can measure charge. So the four primary things in physics that you can build practically everything else from, composite units: um, length, charge, time, and mass. So with those, you can build something like the Newton, which is the kilogram meters per second squared, or the joule, which is Newton meters, or the watt, which is um, joules per second, et cetera, et cetera, et cetera. So all the point of this is you have very well defined units and ideas of the notion of what a physical quantity is, and it's a very desirable property. For example, if you have 1 kilogram of an object, it's going to be a kilogram. It doesn't depend on the environment that it's in. It could be hot, it could be cold, it could be in space, it could be underwater, as long as it's not dissolving away or whatever. It's going to be 1 kilogram. Not so with fitness, and that makes it very difficult then, because that lack of persistence and definition and that total ambiguity makes it difficult to make scientific claims. Because then, if you don't know what the environment was in the past, how can you assert that it evolved something toward complexity? You have faith statements upon faith statements of things you cannot prove, verify, or have access to, saying that it did this. You accept it on faith, not on fact. That's why, to quote Jerry Coyne, in science's pecking order, evolutionary biology lurks somewhere near the bottom, far closer to the pseudoscience of phrenology than to physics. Whether that was its intended meaning, as written, it was actually pretty accurate in my opinion. So let's continue here. To give a simple example, laboratory evolution experiments in microbes often use cell division rates of bacterial strains as an indicator of fitness. While growth rate is certainly an important aspect of fitness, a myriad other equally important aspects exist, including survival under starvation conditions, heat resistance, sporulation efficiency, germination rates, and so on. In addition, growth rates themselves could be measured in countless different laboratory environments. Which of these would be most representative of the environments a microbe encountered in its recent evolutionary past? The answer is usually unknown and perhaps unknowable. So if you're going to believe something is true, but it's unknown and unknowable, that is a faith statement. Such problems are exacerbated in higher organisms where sexual reproduction, age-specific mortality and fertility, and increased ability to change the environment, and smaller population sizes pose daunting principal and technical problems. Taken together, these difficulties mean that an unassailable measurement of any organism's fitness does in practice not exist. And I've read that several times at DapperDino. All his comebacks are slimy Sal. Like, okay, I get it. It's easier to talk about slimy Sal than it is to deal with real theoretical problems like this poses. Because if a quantity is unknown and unknowable, how can you determine that how it evolved over time? Dapper, you need to think a little bit about that before you claim evolutionary theory is a good theory. This is really problematic, dude. I mean, you could say it's a good religious theory. Okay, I might disagree with that, but it's a religious theory. Don't represent it as a scientific theory. You're going to get slaughtered. It's going to be really embarrassing. So this thing by Andreas Wagner references reference 12. And reference 12 goes to a paper by Lewontin, and I know it off the top of my head. It is the Santa Fe Winter Bulletin 2003, 4 complications with the evolutionary process. And let me see how closely I got to the title. There it is. I'm sorry, 4 complications in understanding the evolutionary process. Santa Fe Bulletin 2003. It's actually the Winter Bulletin. You can Google it. You're going to have a hard time finding it, but it's there. You'll find it. So now that one was unfortunately a little too terse. Let me see if I can even get it. You can get it through Google Scholar. Let me see if it'll come up. Yeah, you can get it through Google Scholar. You just click on there and you'll get this. Now, the explanation in this essay was not as in-depth as Lewontin's other publication, which happened to be The Confusions of Fitness. Now, I'm going to point back to my debate with DapperDino. He was insisting, the evolutionary definition of fitness is adequate. And I said, no, it's not. No, it's not. And this is December when I only just started working on the project that eventually passed peer review on evolutionary fitness, fitness maximization in evolutionary biology. I worked on that for 4 months or more, and it passed through peer review, got accepted, Springer Nature, reputable publisher. It's now on university shelves. So even in this debate, we were debating it, but I didn't have the arsenal I have now. And the arsenal, I think I mentioned it specifically in this debate. I'm pretty sure. I referenced Lewontin's Santa Fe 2003 bulletin, and I specifically mentioned density-dependent selection, but that just seemed to float. The problem that posed seemed to float right over DapperDino's head. And I can understand why, because it's a difficult topic. But it is better elaborated in this peer-reviewed article that was in the British Journal for Philosophy and Science, and it's by Andre Arieu and R.C. Lewontin. Now, the order of the authors is alphabetic. Lewontin went to great lengths to point that out. Because if you read this, it really reads more like Lewontin than Arieu. Not to detract from Arieu at all, who seems to be a very fine computer scientist now at MIT. But you could read this here, but I like the one that Arieu himself has put on his website, because this is the draft. Oh, thank you for the kind words. So, I read Andreas Wagner's kind of more English-like and comprehensible description, but I'm going to get into the details out of necessity. Unfortunately, like a lot of philosophers, they use a lot of flowery language that just doesn't really help in understanding. It almost seems to just make things look more impressive than they actually are. And Pigs Can Fly says, I keep pointing. I'll let you all read that. I need to get a drink to soothe my throat. Just give me a moment and I'll be back. All right, I'm back, guys. Thank you for your forbearance. I'm having some Bigelow tea with Dunkin' Donut creamer and half. The Bigelow product is Constant Comment. Has that orange taste with it. Delicious. So, DapperDino gets a spanking on the obfuscations of evolutionary fitness. So, going back to our debate, why can I claim he got a spanking? Because I'm going to cite an evolutionary biologist. And look at the title, The Confusions of Fitness. Anyone who knows Richard Lewontin knows he was like one of the people at Harvard in the era of Stephen Gould and Ernst Mayr. And you had Lewontin. Yeah, Harvard University. Lewontin, The Confusions of Fitness. And our debate was over this. So Dapper, you're going to get spanked by Richard Lewontin. I'm not. I'm only going to comments that I might make is to clarify some ideas that he had. But sorry, buddy, you don't even know your own theory as well as you should. You should understand. You went there on a debate, and you're basically repeating a lot of evolutionary talking points because a lot of evolutionary biologists are not familiar with the population genetic insights of Lewontin. As respected as Lewontin was, I guess he didn't toe the party line, shall we say? But he was right, and you're going to hear it right here. So if we had to do this debate over again, DapperDino, I could just as well read from this, and you'll see you would have lost that debate. Score 1 for Lewontin and a spanking of DapperDino. You can read it here if you really want. In the interest of time, I'm going to have to just breeze through some sections. But in his essay, let me see here. He says in his essay, the one in Santa Fe, it's not entirely clear what fitness is. Says it right here. The problem is, let me get this a little bigger. The problem is that it is not entirely clear what fitness is. Yeah. Thank you. I mean, did I say that? I quoted it. It's not entirely clear what fitness is. So, Dapper, you're getting a spanking not from me, but from one of your own. And that's got to hurt even more, buddy. So I have a recording session with Rebecca. We're going to be talking about hell. And we'll release that. We agreed to release that video at some point. We're just going to record it first before we release it. But let's go through this. The language is pretty thick, unfortunately. And just for the sake of clarity, the order of authors reflect an alphabetical order only. So that means Ariu begins with A and Lewontin with L. So it could be that Lewontin is the senior author. It doesn't matter. He was a co-author. So let's read it. Our purpose in this essay is to show that the concept of fit, as introduced by Darwin, does not appear in quantitative dynamical theories of genetic change and evolution. Any attempt to introduce a unitary analogous concept of reproductive fitness into dynamical models is the scalar ordinal, which will explain or predict quantitative changes in the frequency of types, must fail. Must fail. You get that, DapperDino? Your advocacy of a single quantity, it's going to fail. Okay, I'm going to just fast forward. Basically, you can't tell if one creature's more fit than another because it depends on an environment. Just go to the pepper moth example. In one environment, one trait's more fit, and another trait's more fit. That is very problematic because at some point, the first problem is unless you know what the environments are, you can't really make scientific statements about the history of an organism except to say, well, it had the right environment to evolve it, which is not a scientific theory, really. Seriously. You're just guessing. You're believing. Faith statement. The next problem is it kind of negates the kind of insinuation that fitness as in complexity has an inherent tendency to evolve naturally, and that kind of fails there because again it's dependent on the environment, and many environments disfavor complexity. As proven by the experiments I cited, if you were paying attention, like genomes decay despite sustained fitness gains, and selection-driven gene loss, and genome reduction is the dominant mode of evolution. So let's continue with the spanking here, DapperDino, by one of your own, not me. No concept in evolutionary biology has been more confusing and has produced such a rich philosophical literature as that of fitness. The confusions have arisen because a concept originally introduced as an inexact metaphor by Darwin has come to play an analytic role in the formal quantitative dynamics of quantitative dynamics of evolutionary biology. The confusion has arisen from the mistaken belief that a single coherent definition of fitness is required and can be applied over all dynamics of evolutionary genetics. There is a conviction among philosophers and biologists that somehow a property of fitness must be included in dynamical explanations of evolution through natural selection. Our purpose in this essay is to show that, one, the concept of fit as introduced by Darwin, both in the explanandum and exponans of his theory, does not appear in quantitative dynamical theories of genetic change and evolution. Any attempt to introduce a unitary analogous concept of reproductive fitness into dynamical models is a scalar ordinal which will explain or predict quantitative changes in the frequency of types must fail. This failure is a consequence of the fact that in different biological situations, different algorithms must be used to connect temporal changes in type frequencies with quantitative information about reproduction, and that in an important fraction of cases, even complete information on reproductive rates is insufficient to determine whether a type will increase or decrease relative to others in the population. The concept of fitness for Darwin, he did not actually use the term fitness, but did refer to individual organisms as being fitter or more or less fit than other individuals, arose from his view of organisms and environment. The essence of Darwinism, the essence of Darwinism! It's not just creationists who use the word Darwinism. The essence of Darwinism was the rupture between the causes of the properties of individual living beings and the causes of the structure of the world they occupied. Let me just pause here and talk about, as I'm going to not be able to read all 24 pages, oh my goodness, in this short space. Single scalar ordinal. Okay. Example, body temperature. Single scalar ordinal. It's ideally at 98.6. If we take, the mouth. Oh my goodness, look at this. Cindy Lincoln is here. Scalar ordinal. Heart rate, averaged over a minute. Single scalar ordinal. So how does a medical doctor determine if you're physically fit? Does he just use one metric? No. When he's doing a physical exam, he's going to look at all the metrics. Do you have any heart murmurs? Do you have tachycardia? So a good heart rate would be about 60 beats per minute. That's considered quasi-athletic. You have blood pressure. So my blood pressure hovers around 90/60. 90/70. You have body temperature. My body temperature tends to be cold, like 97 degrees rather than 98.6. By the way, they say that that's an indicator of longevity if you're a little bit cold, body temperature wise. So you have, and then body mass index. So, or it tries to estimate your height. It takes your height versus your weight, and it'll say, okay, you're a little on the fat or skinny side. So look at all this. The way we measure fit in the medical sense is multiple numbers, multiple scalars, right? Body temperature, body mass index. They could tell if your eyes are able to see what the acuity level is, like 20/20. Whether you need corrected vision, they measure your the spectrum of your ear with frequencies it can hear. Your heart rate, your blood pressure, your cholesterol metrics, and then you can have all these blood panel assays that measure all sorts of things like your hormone levels and your levels of a variety of chemicals. Then you have a fitness profile. That's how a medical doctor will assess that you're fit. It's very similar to the way an engineer would measure the fitness of an aircraft to perform in certain environments. You have all these metrics. It's a little, and that was the subject of our debate. And again, if I had to do this all over again, and not that it would fit in the modern day debate rules, because they're about theater, not necessarily the truth. When DapperDino, debated the topic, evolutionary fitness, pro or con. If I were to do this today, and like I said, at the time, I had only just begun the project on the analysis of the problem of evolutionary fitness. I had a few things in my arsenal. But like today, DapperDino would be totally given a spanking by his own as I read Lewontin. This is just a total takedown. This is brutal. And so, DapperDino can call me all sorts of names, this or that. Let's assume for the sake of argument, I'm all the nasty things he said about me. Does that in the end matter? Doesn't it really matter whether evolutionary theory is credible science? Because if it's not, then maybe there is a creator. Maybe life didn't create its own complexity. Maybe it was created by a creator God. So that's the point of that. And yeah, I kind of get it. DapperDino doesn't have much to resort to than ad hominems at this point, because he would have to be arguing against biologists like Richard Lewontin, who's an expert on fitness. So back to Lewontin, and this is 24 pages. I'm just going to skip. So let's see some examples. It's better to give some examples. All right, there's, oh my goodness, there's some really brutal. I read this in a 5-hour show, cover to cover, start to finish. And I don't know that how many of Dapper's fan club actually watched it, and whether he watched it. It would have done him a lot of good if he did. He wouldn't be saying some of the stupid things he's saying. So, okay. So let's look at this frequency-dependent selection. The assumption in the standard viability model that fitnesses are independent of the frequencies of the genotype is generally incorrect. It is quite common that rarer types are at an advantage, as in the famous cases of butterfly mimicry, where the advantage of having a pattern resembling a species that is distasteful to predators decreases as the palatable mimic increases in numbers. Fitness in frequency-dependent models is not a scalar, but a set of functions. Fitness in frequency-dependent model is not a scalar, but a set of functions of genotypic frequencies, so that it is not possible to order the fitnesses of the genotype except at a given frequency. Yes, thank you for watching it, thank you for watching it. All right, so using the terminology of functions in analytic geometry, you would have f. If you had a single scalar, you'd have something like f equals 1 or f equals 2 always for all values of whatever of the domain. Whereas when you have f of x, f depends on x. In this case, x would be the frequency. So you don't have a single scalar. This is already starting to be bad. Okay. This is bad. This is bad. I mean, this is just the start. Lewontin goes through so many examples. I'm just going to breeze through them. And I have a witness here. My unfinished journey saw me read the entire paper in its entirety. Okay, so I'm just going to skip. I know where to skip to because I've already read it. All right, so here's a fertility model. Suppose type A always produces 2 offspring while type B produces 1 individual in the same generations and 3 individuals in others with equal probability. Thus, the expectation of the reproductive rate of the 2 types is equal to. Suppose we begin with 2 individuals of each type. In the next generation, there'll be 4 of type A and either 2 or 6 of type Bs with equal probability. Then the expected relative frequency of the 2 types in the next generation is type A's 0.535 and 0.465. This discrepancy between the equality of expected reproductive rates and the inequality of expected relative frequency in the next generation arises from the difference between the expectation of a ratio and the ratio of expectation. The type with the lower variation in reproductive rate has the greater long-term expectation, which then is the correct measure of, this is a rhetorical question, which then is the correct measure of fitness. Ouch. Ambiguous. Again, the problem of trying to reduce this to a single scalar. Overlapping generations. The spanking continues, DapperDino. A major fraction of living species, like humans, do not have discrete, non-overlapping generations. Each mating pair produces offspring over an extended period, and these in turn reproduce over many ages. So, this is really difficult. We get into fissures. This is an Euler equation. I wish they used the better typewriter. I think this is a summation symbol here, and you can get the Euler equation. I covered that before in my other show that started with Rebecca. And, oh my goodness, Charles Worth and Giesel, 1972. Let me just, all right. I mean, DapperDino, if you want a spanking, let me see if I have this. Charles Worth and Giesel. I mean, you know, at least I try to study this stuff, which is more than I could say for you. Because one, I had co-authors and I had to try to protect them since they're my co-authors when we publish. I want you to look at this paper that Lewontin is referencing. So Lewontin references this paper by Charles Worth. And why am I showing all this nerd torture-y math? As Lewontin studied this, okay, this is the population genetic stuff. And Lewontin realized, okay, I'll give you the bottom line. So Lewontin references the paper I just showed with all those mathy equations. And he was saying, when you have, okay, so a human being, for example, he doesn't have all his kids all at once, right? You have them, spread out over ages. Then you have the mother and father. So you could have a father with a spectrum of ages and a mother a spectrum of ages that she's bearing children, and they can bear a variable number of children. So all that mathiness there is trying to capture these details. You could see the problem gets really difficult very fast when you include the fact that they're bearing children at different ages and different quantities. And you would think it would not impact the definition of fitness, but it does. And here the spanking goes on. Charlesworth and Giesel give an example of two genotypes with different reproductive schedules that differ in the timing of reproduction, such that the first reproduces its offspring at an early age, while the second delays reproduction to a later age. If the population as a whole is increasing in size, the first precocious genotype increases in frequency, while if the population is decreasing, it is the second genotype that increases to the first. We are forced to conclude that for species with overlapping generations, that is, for a very large fraction of organisms, no scalar reproductive fitness measure can be derived from reproductive schedules that allows the statements of the form type A is more fit than type B. This is really bad. The spanking continues because if you have in your population ladies that like to have their kids early versus ladies that have them late, whether one is more fit than the other will depend on whether the population size is increasing or decreasing. So take that. Spanking, another spanking. DapperDino gets spanked again. Oh my goodness. Oh, this is brutal, DapperDino. I mean, you should have never started this fight. Fitness as an outcome. So then they talk about, well, let's just count the number of creatures, and that's how we decide fit. And he goes into why this is problematic. This is kind of in the mathematical areas of it. And this one's interesting. And the spanking goes on. Ramets and genets. Violets reproduce in two ways. And I have about 10 minutes here. And since Cindy is into plants, she'll appreciate this. Violets reproduce in two ways. A flower may set seed, and these seeds, having dispersed, may each give rise to a new plant. Alternatively, a violet stem may send out underground runners, which, at points along their lengths, put up flowering stalks. A plant produced from seed is a genet, while one produced above ground asexually from a runner is a ramet. The problem that has plagued evolutionists, Okay, get that? Dapper, as you're being spanked, this is a problem you evolutionists have to deal with because it's a problem that's plaguing you. The problem that has plagued evolutionists who deal with organisms that have both sexual and vegetative reproduction is how to count ramets and genets in assigning reproductive fitness. Do all the ramets of a single original stem count as belonging to a single individual, or is each to be counted as a separate individual? It might be argued that since the ramets are all connected as a single body, they are collectively one individual. But is the occurrence of a break in the underground stem sufficient to produce a new individual for accounting purposes? Moreover, the problem exists for trees. A tree consists of a large number of flowering stems connected together by branches and a trunk. Why should it matter that these flowering stems are connected above ground rather than below? If a tree is a single individual, then so is the collection of all the ramets of a violet. How is fitness to be calculated in such instances? Suppose an entire field is occupied by hundreds of ramets from a single original plant, except that in one spot there is a single plant that is a genet of a different type. Are the two types to be counted equally frequent? In a colonial organism, say a coral, is a type that produces a single colony that spreads to occupy nearly the entire territory available to species less evolutionarily successful than a type that reproduces 100 scattered sexually reproduced organisms, each of small extent. It would appear the problem of fitness and relative evolutionary success demands a solution to the problem of defining an individual. Spanking, spanking, spanking. The problem raised by individuation is a consequence of the Malthusian origin of evolutionary theory. The bookkeeping of evolutionary biology in terms of numerosity is the transfer onto the evolutionary problematic and onto a great deal of ecological theory as well of the central problem of human demography. The growth in numbers that arises from using as a model a sexual species that reproduce solely by giving birth to clearly defined individual objects that all grow to approximately the same size. As an alternative, it would be possible to build a dynamical theory that used not numbers, the innumerable objects, but a continuous measure of occupancy of the external world. For example, the total amount of living protoplasm belonging to a given type. Indeed, the Malthusian preoccupation with numbers stemmed from the preoccupation with the supposed limit in the resources available and the struggle to acquire those resources that were in limited supply. But success in sequestering resources in short supply is measured by the total amount sequestered. In the special case that there are well-defined individuals of approximately the same size, numerosity is a proxy for total resource, but it is only a proxy. And I could continue here. And so now they talk about the difficulty replacing numerosity with limiting resource. This is bad spanking here, DapperDino. You need to read this. This isn't creationist literature. This is from one of your own. And just to rub it in a little bit, in light of our debate, the facts have argued on my side. Therefore, I win. Not because of my intellect, but because of Lewontin and Eriu. And it says here, conclusion. It appears that the resolution of the confusions about fitness, yes, there are confusions, contrary to what DapperDino argued with me in December 2020, there are confusions and it's bad. It appears that the resolution of the confusions about fitness requires both the abandonment of the attempt to make a general quantitative dynamical theory of evolutionary change in which a unitary scalar reproductive fitness appears as a parameter, and the acceptance of a diversity of specific dynamical models in which variation in reproduction among heritable types appears in structurally quite specific ways. End of story. And yeah, he got a good spanking. Let me see, Alan or Alan Orr in this paper, Fitness and the Role in Evolutionary Genetics. Biologists have offered a staggering number of definitions of fitness, and this is problematic. Yes, I'm wrapping up. Rebecca and I have a discussion about what the scriptures say about hell. She's giving me a hard time here. The clock's running out on me. You see, we can have equivalent definitions of mass, for example. And there might be some disagreement, like multiple places far beyond the decimal point. But whatever one's definition of mass is, I could take a kilogram here, bring it to someone else in another environment, and they'll say it's a kilogram. That's stable. The thing is you don't have to concoct. There is a way you can objectively measure it, and it's also independent of the environment. So I could take a mass of 1 kilogram, bring it to the moon that has 1/6 the gravitational acceleration in a vacuum, and it still be 1 kilogram of mass. Its weight will be 1/6 because of the gravitational field, but the mass will still be the same. And whatever the other guy's definition of mass is, as long as he will measure it as 1 kilogram, we are able to objectively um, say what something is. When you have a staggering number of definitions of fitness that are dependent on the organism and the environment, you don't have any stable definition. And what makes this really bad is then you cannot make scientific inferences, because if you don't know the environment in the past, how can you assert that it evolved naturally to this or that, except by faith statements and speculations? So with that, I have to get ready for my discussion with Rebecca about hell. We planned this morning to kind of air our theological differences and to do it publicly for the benefit of our listeners. So I'm going to close this out with some music. God bless you. Thank you all for joining this stream today. DapperDino gets a spanking on the obfuscations of evolutionary theory. And I did mention Darwinism as religion. That alludes to Michael Ruse's book, Darwinism is Religion. You can get it, Oxford University Press. So that covers all the things on my docket today. So enjoy, have a blessed time. If you don't, accept him as Lord and Savior so that you won't go to hell. And Rebecca, I'll see you in maybe less than 2 minutes. God bless you all. Take care.